Statistics is a powerful tool. It helps us understand the world around us. At its core, statistics is about collecting, organizing, analyzing, and interpreting data. It's about finding meaning in the sea of numbers that surround us. This field is broadly divided into two main branches: descriptive statistics and inferential statistics. Imagine you have the test scores of 50 students. Descriptive statistics would help you summarize these scores, while inferential statistics would allow you to make predictions about the entire student population. Descriptive statistics focuses on summarizing and presenting data in a clear and concise way. It's like painting a picture of the data, highlighting its main features. This branch uses measures of central tendency, such as the mean, median, and mode, to show the typical value in a data set. Measures of spread, like range, variance, and standard deviation, reveal how spread out the data is. Data visualization tools, including bar charts, pie charts, histograms, and box plots, further enhance understanding by presenting data visually. For example, calculating the average age of students in a classroom is a descriptive statistical operation. It simplifies the data, revealing patterns and trends. Descriptive statistics helps us understand the characteristics of a data set. It provides a snapshot of what the data looks like. It doesn't aim to make predictions or draw conclusions about a larger population. It simply describes what is observed. Inferential statistics takes us a step further. It allows us to use data from a sample to make inferences or predictions about a larger population. This is particularly useful when studying the entire population is impractical or impossible. Key concepts in inferential statistics include population versus sample, hypothesis testing, null and alternative hypotheses, p-values, and confidence intervals. Imagine wanting to know the average height of all students in a university. Measuring every student would be a monumental task. Instead, you could use inferential statistics. By taking a representative sample and using inferential statistics, we can estimate the average height of all students with a certain level of confidence. This branch of statistics empowers us to make data-driven decisions and gain insights, even when we can't study the entire population directly. Comparing the two approaches. A side-by-side look. Feature: descriptive statistics versus inferential statistics. Definition: descriptive statistics summarizes and presents data, while inferential statistics makes inferences about a population based on a sample. Data scope. Descriptive statistics describes the sample data only, whereas inferential statistics goes beyond the sample data. Techniques. Descriptive statistics includes measures of central tendency, measures of spread, and data visualization. Techniques. On the other hand, inferential statistics involves hypothesis testing, confidence intervals, and regression analysis. Examples. Descriptive statistics might involve calculating the average age of students in a classroom. Examples. Inferential statistics, however, could be used for predicting the average height of all students in a university based on a sample. The dynamic duo working together for better decisions. Both descriptive and inferential statistics are essential for research and making informed decisions. Descriptive statistics helps us organize and summarize data, making it easier to understand. It provides a clear picture of what the data tells us. On the other hand, inferential statistics allows us to go beyond the data we have and make predictions about a larger population. This is invaluable in fields like medicine, business, and social sciences, where decisions often impact a large number of people. For example, imagine a pharmaceutical company developing a new drug. Descriptive statistics would be used to analyze data from clinical trials, summarizing the drug's effectiveness and side effects. Then, inferential statistics would help determine if the drug is effective enough to be released to the market, considering the entire patient population. In conclusion, statistics as a guiding light. In a world overflowing with data, statistics serves as a guiding light, helping us navigate the complexities and make informed decisions. Descriptive statistics paints a clear picture of the data, while inferential statistics allows us to venture beyond what we can see and make predictions about the larger world. By understanding and utilizing both branches of statistics, we empower ourselves to make sense of the information around us, leading to better insights and more effective decision-making in all aspects of life.